hit it. The more challenging part is figuring out how do you get the power for it, and that's where a lot of what we've worked on for existing like Starlink technology, the solar arrays, are what we want to utilize that expertise to be able to build a satellite that can actually launch the critical components of the data center into space itself. We like to look at this and say, like, what is the actual engineering problem here? And it's really a combination of delivering power and then taking the waste heat and energy away and sending it into the vacuum of space, as you mentioned.
This is our AI1, if you guys want to walk us through.
Yeah. So the first thing that we're really looking at here is, like, first you've got to make something compelling, right? And we thought that the right place to start is around the 150 kilowatt like peak power level. But as we look at the workloads with our experience with XAI, we get to actually see that we can also support about 120 kilowatts of average compute. There's a difference.
Yeah. What we're showing here is kind of a draft version of the version 1 of the SpaceX AI satellite, an AI1, I guess you could call it. And seems like a reasonable place to start is 150 kilowatts peak power, 120 kilowatts sustained power, and to give you a sense of what does that actually look like in terms of the size of the radiators, size of the solar panels. The assumptions here are 250 watts per square meter for the solar array, and about 1,400 watts per square meter for the radiators. So the radiators, these are double-sided. Radiators are radiating both sides. They're oriented knife edge to the sun, and it's 1,400 watts per square meter is a very achievable goal. Over time, we think we can probably do above 250 watts per square meter and above 1,400 watts per square meter for the solar panels and radiators, respectively. But this gives you like this is pretty much what the satellite's going to look like.
Yeah.
It's a lot of solar panels, radiator, and then everything else is pretty small by comparison.
And these are like evolutions of things that we have actually already launched in our Starlink constellation to date.
Yeah.
That's really, I think, the cool part to me is that we're looking at solar technology that we already are going to use on the V3 Starlink vehicle. So I'm like really excited to then just take those and make it bigger.
Yeah, part of what we want to convey here is that there's not some magic that's necessary that doesn't exist for the AI satellites. As Ian said, a lot of this is technology we've already made for the Starlink V3 satellites.